Right, so we've got this quadratic equation. We're told it has roots alpha and beta, and we're asked to find the value of alpha plus beta and alpha beta. So it's a roots of quadratic question, and we're asked to find the sum and the product. So the key rule is this here. The x squared minus the sum of x plus the product equals 0. So that tells me that the sum is the negative coefficient of x and the product is the constant when in the form x squared. Alright, so if you've got a number in front of you x squared, you'd have to divide through first. So in this case I've got the single x squared, so I can see that minus the sum of x, so that the sum, which is alpha plus beta, would just be 4. And we have plus the product, so here we have plus 10. So alpha beta equals 10. So we're asked to show that 1 over alpha plus 1 over beta equals 2/5. So it's a show that question, so I'm not going to involve the 2/5 in the solution, that's going to be the final answer. So I need to somehow make 1 over alpha plus 1 over beta be made up of alpha betas and alpha plus betas, because as soon as they're made up of those, I can sub in the values that I know here. Okay, so you can see here that when we add fractions, we need to make the denominator the same. So I've times the top and the bottom of this by beta, as you can see here, and I've times the top and the bottom of this fraction by alpha, as you can see here, and now I've got alpha beta, beta alpha, which are the same, so the denominator is the same, so we can add. So we get alpha plus beta over alpha beta, which, subbing in our values that we've found earlier, we get 4 over 10, which simplifies to 2/5. So now we're asked to find a quadratic equation with integer coefficients which has these roots. We've got our original values still, so we're going to do the same again, where we're going to try and find the sum and the product of these roots to enable us to put it into this form. So here we've got the sum of our roots, so I can shift that alpha and beta to one side on its own, because I know the answer to that already, and then I've got the two fractions that I'm left dealing with. Now what hopefully you can see is that these here, if you take out a factor of 2, you're actually left with this. So now we can just sub in the values that we know. We know alpha plus beta is 4, and we also from part B know that 1 over alpha plus 1 over beta is 2/5. So we can now work out the final value. So we've got 4 plus 4/5. Writing 4 in terms of fifths would be 20/5. Having the denominators the same, I can now add them to get 24/5. And I'm going to leave it like this for now. Right, now you're going to find the product. Now I would urge you to take care and to slow down when you're multiplying out two brackets like this, and if need be, use a grid method. Okay, so we've expanded the brackets, and then I've simplified it, so I got left with 2 beta over beta, for example, so the beta's cancelled. You can see what we've now got. We've got alpha beta, which we know the value of. We've got two numbers, which obviously are fine, and we've got 4 over alpha beta, so we can simply just sub in our values. So we've neatened up the fractions. I've written 14 as 70 over 5 to enable me to add those fractions to leave me with 72/5. So we've now got the sum and the product, so we can put it into this form. Okay, so this looks right apart from one little thing. If you notice in the question it says with integer coefficients, so I need to get rid of these 5's on the bottom, so I'm simply going to times each term up by 5, and I can do this because I've got this equal to 0. And that gives me my final answer, 5x squared minus 24x plus 72 equals 0. That's the quadratic equation that has roots alpha plus 2 over beta and beta plus 2 over alpha.